Scientists have discovered a six-planet solar system out in the Milky Way. Astronomers say it is untouched by outside forces since its birth billions of years ago. The six planets orbit a star perfectly in sync, which is part of what makes it so rare and so interesting. It's 100 light years away, and for perspective, 1 light year is almost 6 trillion miles. So to understand more about all this, let's bring in Chief Astronomer at the Franklin Institute in Philadelphia, Derek Pitts. Derek, good to have you back with us. Talk to us about why this is such a rare and important discovery, that the solar system is perfectly in sync.
What this reflects, Lara, is that it is what a solar system looks like right after it's born. I mean, that's what we're seeing here. The planets are in perfect synchronous orbit with each other. There are 6 planets altogether. 5 pairs of the planets have these synchronous orbits. This is how we think solar systems are born. So we're looking at what a solar system may have looked like billions of years ago, even what our solar system may have looked like billions of years ago when it first started. Now, over time, of course, what has happened is different dynamic forces like interloping objects have disrupted that in other solar systems, in most other solar systems. So in this particular case, we're seeing what a very early solar system may have looked like.
Yeah, I think that I read that the innermost planet orbits 6 times for 1 rotation for the outermost planet, and that they're all doing this in what looks like a beautiful ballet. Of course, our solar system has been banged around by different heavenly bodies, so we're a little bit more wobbly, if you will.
Very much so.
So what are scientists then learning from this discovery besides just appreciating the sheer beauty of it?
Well, it's difficult to actually look at a solar system like ours and sort of do what I call forensic astronomy, looking back over time to imagine what the dynamic conditions were like in the early solar system. Now, here in our solar system, astronomers have done very well to have some sort of a guess of what the early solar system was like. But when we look at a solar system like this one that has these planets in resonance, it allows us to have a model that we can begin from to imagine what our solar system might have been like. Now, here's the complicating factor. There was so much dynamic activity in our solar system at the very beginning. Our solar system right now looks nothing like what it originally looked like. I mean, as far as the placement of the planets is concerned and what planets were here and all that sort of stuff. But we have to begin somewhere, Lana. We have to start someplace. So we look at what we have now, look at a solar system like this one, where the planets are in this nice synchronicity, and look at a number of other planetary systems that show the same thing. And hopefully we can figure out how our solar system got to be the way it is.
Derek, you know, I have so many questions. We only have a little bit of time. I mentioned that this is trillions and trillions of miles away. To cut to the heart of it, everyone always wants to know, what's a possibility that any new space discovery can sustain life?
When we look at these planets that we see right now in that particular system, most of them are bigger than Earth, but smaller than Neptune. And the telescopes that we use to examine them can only tell us so much. But we know a couple of things. We know that some of the planets are too close to their star. They're not in what is called a habitable zone, a zone where the temperature is conducive to the presence of liquid water. But that's not to say that there aren't other systems around that show some synchronicity that do have planets in what we would call a habitable zone. So maybe we'll find some as we keep exploring the universe.
Keep exploring. We know that you're discovering new solar systems all the time. We will invite you back on every time you find something else new. Derek Pitts, thank you.
Thanks, Lana.